Well, greetings everyone, and welcome to Tim Time Projects. Couple of things. I don't have any real big projects to do today, but a couple of things I was thinking about one was when I was working on the garage door opener. I thought, well, if only I had a radio that I could receive somewhere in that area, I could see if it's putting out a signal. But I didn't. I have some old radios over there. Nothing in the UHF bands, that area, that low or that high anyhow. It's, if you look up the part number on that controller, it says it should be around 390 megahertz. So I'll show you what I did. I turned on the doohickey, my poor man's spectrum analyzer, the RTL SDR, and no signal. So I'll show you kind of what I started to do, and not really sure why this happens, but I know when it sends out, it doesn't send a normal signal. It kind of sends like a data blast out, and you can pre-program it. There's like 10 billion different codes that you can have. So I'll just kind of show you what I had. Let me get this back, and then I don't want to do too many things at one time. But so I'm going to tune this to 390. Oh, poop. Let's see, 3, and I'll get the camera up there. I have an app that I downloaded. What a good-looking guy that is! But I have an app I downloaded for a phone, and I can see what's on the GoPro, because the problem is with my other camera, I can spin that one over there. You can't see it. I can spin the monitor around so I can see what it's looking at. But with this, I can see from here. That's why I have to keep kind of looking down to see if I'm still in the camera and haven't moved off to the side. Since I'm by myself, I have a tendency to do that a lot. So let me get it up to there, and we'll see what we're looking at, and I'll show you. Like I said, this little guy is supposed to be 300, can you see it? Yeah, 390 megahertz, and that's where I was looking, and I'll show you. So let me get you tuned over there. Alright, so there's let me get to 390. Here are the craziest things here. I was trying to track down what some of them were. So I'm sure some of them are the wall wart chargers that everybody has. Alright, I have it spanned out pretty wide. As you can see, it's going from about 389 to about 391 something. So we should see something, hopefully. So what I'll do is, and it's going to be kind of hard, and I'll show you what I'm doing. But anyhow, I'm keying this up into an antenna, and there's nothing. I see nothing. And I've gone up and down all through this band. I see nothing. So I thought, well, maybe that's not putting out a signal. I don't know. Maybe I broke it when I was trying to fix it. So let's zoom down to the oscilloscope now. There's Larry's buddy right up there. Okay. So what I did here was, just for the oscilloscope, I created just kind of a loop antenna. All I did was put a loop of wire around this thing, and one side's the common, and the other side's the hut, or the center probe. And you can see when I key it, I get a signal. So, move this out of your way here a little bit. Let's count the blocks real quick. 1. So for one oscillation, it's a little over maybe 1.2 blocks. And let me show you. That's not what I wanted. I'm on the 2 nanosecond scale. So 2 nanoseconds, and then each block's 2 nanoseconds. So let's say nanoseconds. So let's see. So it comes out to be 1.2 2.2 blocks times 2, because each one's 1 nanosecond or 2 nanoseconds. So it comes out to be 2 point some, we'll say 2.2, 2.4, 2.2, somewhere in that area. So now what you want to do is turn that nanoseconds and then take the reciprocal, and that'll give you frequency. But what I have here is, let me see if I can do this without screwing everything up. You know, the internet has everything. Now I'm trying to, I had a Android phone forever, and now I'm trying to get used to using an Apple phone, and then I'm trying to get used to going back to an Android. So give me a second here. Oh gosh, where was I? So just go on the internet here, and I just typed in 4.2, well actually I wanted 2.2 nanoseconds to frequency. I thought I was on the other scale, but so, and I can't see what I have, but that's what I typed in. But anyhow, there's a converter here. So what I was looking for was what frequency. So the first thing I tried was 390, because that's what they're telling me. 390. 2.5. Well, that's a little bit high. I'm looking for what I say, I had 2.1, I think. And I was in a 1.1 to 1.2, then times 2. So that's a little bit high. We're looking for somewhere between 2.1 and 2.2. So I just started playing with the frequency a little bit, watching what was happening. And let's go to 400. We'll go to 420. That's getting me closer. So I'm not going to go on with this forever, because I don't even know if you can see it. I have to get back to the camera thing. I don't know enough about this GoPro to know what the heck it's doing. Oh, I gotta find it again. There it is. Okay. Oh, now it has to reconnect. I hope it's still recording. All right, while that's reconnecting, I'm gonna tap the monitor, because it looks like it's still recording. Okay, anyhow, so I said, all right, that looks like, let's start looking at about the 425 megahertz frequency range. So, not attempting. I'm going to use the same thing. What I'm using for an antenna is this. It's basically just going into the RTL antenna. You can see it right here. I have it grounded to the ground plane would be that shelf, and then this is just a loop. I know it's kind of long, probably for 420, but you do what you can, you know. So I got back up to here. Boop, 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 boop. All right, let me tune this to around 420. And right about now, the kids will be going, 420, yeah! All right, there's 420 something. Is that what I was looking for? Yeah, I think. Let's get this guy. And then I started to just shut up as I was going up. Where the heck was I again? There it is. See at 427. Watch. This is when you can see it goes through the whole gambit there. Let's see. Let's see at 426. But you can see, so there's the signal, and it's somewhere in the neighborhood of, it doesn't just stay on one particular frequency. It's got almost like a range that it goes, and I guess depending on what you program into that code for one of your codes, or when you program into that device for one of your codes, it looks along that range of frequencies. Kind of interesting. I'll have to do some more research and find that, but I thought it was strange that it was nowhere near the 390, at least the way I'm looking at things. But anyhow, I did find it, and I have to dig into it a little bit deeper and find out. But yes, you can definitely hear it on your radio or your RTL or whatever. That's the garage door opener we were working on. Here it goes again. That's one of the different buttons. That looks like a different code. I don't know. So, all right, so that's that. I knew you couldn't live without all that excitement. So, something else I'm kind of working on here. I'm going to zoom you over. Give me a second to turn the lights back on. Okay. So, over we go. We're going to zoom over here. So remember I put those, let me see if you're looking at what I'm looking at. Yep. A while back we put those LED bulbs in. And I should have checked before I put them in. But I hooked my little power analyzer meter to it. Yeah, let me see if I can get us over there. Let's see, it's showing me. I don't know why I can't zoom in. Why can't I zoom in? Let me see what this does. I don't know what that says. Oh, epic. I don't know what that does, so if something crazy happens in the video. Let me see if I... Hang on. Technology eludes me. I say this all the time. Let me see if I can zoom in from back here. All right, I think that's as zoomy as I'm going to get, I guess. I don't know if you can see that. Oh, that's lovely. I don't know if it auto-dimmed or what it did. Let me turn this out of our way. I think it's auto-dimming it. Maybe if I flip this thingy back over. So anyhow, you can see that the LEDs are on. Big miracle there. Okay. Now, can you see this guy here? Saying 33.7 watts. So that will be the combined with the two LEDs. And I looked them up. I think they said they were like 18 watts. So that's pretty darn close, 18. So that knocks it down to 37. And what's a standard? Aren't the old style bulbs? I think they were 40. So that pretty much cuts your consumption better than in half when you go on a 4-footer. So at least there's that. At least we have that. Okay, and one more thing of interest. Just combining frequencies. And basically all I'm doing is running them both together. I don't have any crazy mixer set up or anything. So I don't know if you can hear it. That's it. And it's combining, no, I'll just unplug so you won't hear anything. But you can still see it on the scope. Give me a second here. Okay. Let me see if I turn that up just a little bit. On that one, and channel 2, and that one. Okay, so anyhow, you can see it on the scope. I'll turn one off. We have 1000 hertz. And turn that one back on. Turn the other one on, it's 100 hertz. So if you look at it, kind of looks like the one signal's riding on the other one. And if we back way out in frequency, you can kind of see that happening. So something of interest, if you put, as you start to get closer, and there's a lot has to do with harmonics and what actually happens when it pluses and minuses a signal. But let me see if I turn this up to, we'll go to frequency, leave that one off 1000 hertz, we'll go to the other one. There's the 100 hertz one. We'll send this up to about 400. There's a 200, you can hear the tone better than at 100. All right, so now you can hear both tones. There's one tone. There's the other tone. But now it doesn't look so much like one signal's riding on the other. Looks like it's creating a bunch of different signals. So that would be your mixer. And if I would have been thinking, I could have built like a little filter, because we could have got the plus and minus. So we would have 1000 hertz, 400 hertz, and then 1400 hertz and 600 hertz. But when you're mixing them like this, I'm sure it's probably not as prevalent to get the pluses and minus. But let's see, we're going to keep going up, because one of the things I found was pretty neat. There's 600, 700, 800, 900, and you can see they're kind of fighting, but and then when they're both at 1000, you get that. Now watch what happens when I go to 1001 hertz on either one of them. That's as they go in and out of phase, the signal goes from nothing to double. Let's turn one of them off, see? It's actually bigger than yeah, so one's at 1000 and the other one's at 1001 hertz. But it kind of gives you an idea how they add and subtract to each other, the absolute value of the signal. And you can even hear it. Let's see what happens when we step away in frequency. Look at that. So they're kind of both fighting on who's going to ride on the signal. It's interesting. Anyhow, just weird things I came up with when I was just starting to put things back on the bench. Thought you might find it as amusing and interesting as I do. Now, let me turn this guy off here. I do actually want to build a regular mixer just to put those together, you know, like an RF mixer, how you use a transistor, and you would control, basically one leg would be going into the gate, and the other leg would be going into the cathode. Yeah, there we go. I'm confusing vacuum tubes. So we'll try that again. I'll get it right yet, but yeah, the one frequency would go into the basically the input or the cathode of the device, and then the other frequency would go into the gate. And what do they call them? Emitter collector. I'm sorry. We'll get it. Yeah, one would go into the emitter, and then the other one would go into the base. That's the term I'm thinking of. Yeah. So the other one would go into the base. So that would turn the signal on at a certain time, as the emitter was turning it on at a certain time. So then when the two times joined together, you'd get your output signals, which would be, the emitter frequency and the base frequency, and then the sum and difference of both of them. And then all you do is you use a filter to take the unwanted frequencies out. So I think it might be easier if we actually build one rather than me trying to explain it and screwing all the terms up. But not today. I just don't have enough stuff put aside yet and pulled out. As you see, I'm just starting to pull things back out. So let's see. I don't even know if it's recording at this point right now. Thanks for watching and spending your Friday night with me. It's a little bit too cold to go outside and do anything. I may go down with the horses in a little bit and do some stuff down there. I can't say for sure. Tomorrow is the Bree Shooters 10-meter CW contest, I believe. Pretty sure it's the 19th. Unfortunately, I haven't been working on code at all. I started off with a bang, a month or two ago, and then I just was so busy with work and everything else I didn't have a chance. But I'll probably still try and jump on there. And if you get a chance to get on there, get on there. I don't even know the times. You can look it up on the Bree Shooters website. And 10 meters doesn't propagate too well at night this time of year anyhow. So I don't think I have anything else to report. So thanks for watching, and I'll get something else put together. We'll definitely do something. This is kind of boring actually. I don't know if you can see me back that water purifier back there. I got to do some work to that, but there's 10 billion videos on YouTube. But what the heck, maybe I'll just throw mine on there as well. I want to replace some items. But thanks for watching, and happy Friday night. Let me turn this thing off.